Hi everyone, it's Gus from Arduino My Life Up. In this tutorial I will be building a simple Arduino motion sensor that makes use of a PIR sensor to be able to detect motion. This simple circuit can be extended to do some pretty cool stuff, for example activate lights, a speaker and much more. In this particular tutorial we will be making use of an LED and a Piezo Buzzer. These two output devices will be able to show us when motion has been detected through the PIR sensor. Our circuit, like most of the projects we have built to date, is pretty simple. You won't require a huge amount of parts to get this working. The first part is the PIR sensor. This is probably the most complex part we have here. The device has 3 wires coming from it. The red is for the positive power source, 5 volts. The black is for ground. And finally the yellow is the output, and this turns live whenever motion is detected. On the PIR sensor you can also adjust the sensitivity and time for the detection of motion. Next we have the Piezo Buzzer. It is a super simple speaker. It has a ground wire and a positive wire coming from it. We will connect the positive wire to the Arduino, so whenever the pin outputs a voltage, the speaker will make a sound. We also have a breadboard, an Arduino Uno, 2 100 ohm resistors, 1 red LED, and finally some breadboard wires. If you want a diagram of the circuit, just head over to arduinomylifeup.com and find the motion sensor tutorial. I will now go into how to wire up the circuit. First run a wire from a 5 volt pin to the positive rail on the breadboard. Now run a wire from a ground pin to the ground rail on the breadboard. Now to connect the PIR sensor up, run the black wire to the ground rail. Run the red wire to the positive 5 volt rail. Now place a 100 ohm resistor onto the breadboard. Run the yellow wire from the PIR sensor to one end of the resistor, and now another wire from the other end of the resistor to pin 2 on the Arduino. Now for the Piezo Buzzer, run the red wire to the breadboard and then a wire from that to pin 3 on the Arduino. Now run the black wire to the ground rail on the breadboard. Now for the red LED, run a 100 ohm resistor from the ground rail to a spot on the breadboard. Connect the negative end of the LED to the resistor and the other positive end to another spot on the breadboard. Run a wire from pin 4 to the positive pin on the red LED. Now before we move on, you may want to double check your connections to make sure they're all done properly. The circuit diagram is probably the best thing to refer to make sure you have the correct connections. Again, much like most of our beginner projects, the code for the Arduino motion sensor will be very simple. This is great if you're just starting out and wanting to learn more about the Arduino coding language. If you want to download the PIR motion sensor code, then you can find it over at arduinomylifeup.com. I will just copy and paste the Arduino script over now. In this first block of code we set 4 different variables. The first 3 are setting pin numbers to a variable. This is so we can easily reference and recognize that pin further down in the code. The 4th variable is where we store the state of our PIR sensor. Low means that no motion has been detected, whilst high means it has been detected. We will keep the sensor at low to begin with. This next block of code is where we set up all our pins and anything else we need to do. For both the Piezo Buzzer and the LED, we set these to be outputs as we want to be able to turn these on and off. The PIR sensor we want to listen to for when motion is detected, so we'll make that an input. Next we set serial.begin. This is so we can debug our code if required. For example, if we write serial.println starting, you will see this in the Arduino serial window. I will show you this window in a bit. Finally we have a delay. This is to allow the PIR sensor to initialize. You can tinker with this value for the shortest delay without the sensor throwing false positives. Next we have the core of our program. The loop function will continue to loop through until the power is disconnected from the Arduino or a new program is uploaded. Firstly we check to see if the PIR sensor is high or not. If it is high, then we enter the if statement, otherwise we keep the LED and the Piezo Buzzer off. When the PIR sensor is high, it means motion has been detected. If the sensor is high, then we turn the LED on and set the buzzer to be a certain pitch by using an analog output. The analog write function can be used to also set LEDs to be a certain brightness, but for this project we'll just change the pitch of the piezo buzzer. We then wait for 100 milliseconds, then turn the LED off and change the pitch of the piezo buzzer. We repeat this until the Pir sensor goes back to being low. The sensor is low when no motion is detected. I will just enter a debug line here to show you in the command line what happens when motion is detected. Once you have the code all done, simply upload to your Arduino and your circuit should come to life. If it doesn't, simply recheck all your connections and make sure the correct wires are hooked up to the correct pins on the Arduino. Also double check the code to make sure there isn't anything that might change the output of the circuit. You can also check the serial output by going to Tools, then Serial Monitor. In here you will see the output from any of our serial lines in the code. I will now set the Pir sensor off by causing motion, and as you can see, it has detected the motion. If you look at the circuit, you can hear the buzzer go off and the LED flash, just like we programmed it to do. I hope you have been able to build a fully working Arduino motion sensor from this tutorial. If you come across any problems, I have missed something, or if there's anything else you want to let me know, drop me a comment below or over at arduinomylifeup.com. Until next time, have a good one. Thanks for watching. Be sure to check out these 21 Arduino projects that anyone can do. If you want to stay up to date with the latest and greatest Arduino projects and much more, then please subscribe.